guys, welcome once again to another video lecture of the tips and tricks of the last chapter of organic chemistry, and that is amines. So we are going to discuss here the important reagents and the conversion tips involved in the conversion type of problems, which will help you to solve all the various types of questions, may it be reasoning questions, arrange the order type questions, conversion questions, what happens when type questions, complete the sequence type questions, complete the reactions, chemical test of distinction. All these questions will be easily able to solve after seeing this video lecture. So let's get started. So nitro compounds can be converted to amino compounds by the process of reduction. When you treat the nitro compounds with any reducing agent, you can convert them into amino compounds. Also, remember that alkyl halides can be converted to amines on treatment with ammonia, and this reaction is called Hofmann's ammonolysis reaction. Alkyl halides to amines by treatment with ammonia. The name of the reaction is Hofmann's ammonolysis reaction. Next, if you see the cyanides in complete reduction using the reducing agent lithium aluminium hydride or sodium and ethanol can be converted to 1 degree amines. The name of the reaction is called Mendeus reaction. Next, the formation of amines from amides. From amides, we can prepare amines in two different ways by using two different reagents. See, this reagent is very, very important. Remember, bromine in the presence of KOH is resulting in the formation of amines with 1 carbon less than the parent amide. And this reaction is named as Hofmann's bromamide reaction, also known as Hofmann's degradation reaction, because it is degrading the number of carbon atoms. Now let us see this side, left side. If you treat any amide with the reducing agent, let's say lithium aluminium hydride, you can convert it into corresponding amine. Corresponding, when I say amine, containing the same number of carbon atom as the parent amide. But if you want to decrease the number of carbon atom, you cannot use lithium aluminium hydride. Instead, you have to use bromine in the presence of NaOH or KOH. And the name of the reaction, remember, it's a very, very important reaction, children, often asked in the board exam. It is Hofmann's bromamide reaction. Bromamide, bromine attacking on amide. Next is Gabriel's phthalimide reaction. Gabriel's phthalimide reaction starts from phthalimide. Phthalimide, when treated with KOH, forms N-potassium phthalimide, where this hydrogen attached to nitrogen is replaced by potassium, forming N-potassium phthalimide. Further on treatment with alkyl halide. Now the alkyl halide chosen should be such that whatever number of carbon atoms in amine we have to form, that many carbon atoms should be there in the alkyl halide which has to be taken. Now this alkyl halide, when treated with N-potassium phthalimide, will form N-alkyl phthalimide. Here it is forming N-methyl phthalimide, followed by hydrolysis using NaOH, so that you get 1 degree amine. 1 degree amine along with the sodium salt of phthalic acid. Now remember that this reaction, Gabriel's phthalimide reaction, 2 reasoning questions come on this, and that is that why it is suitable to prepare only 1 degree amines. Now just see that here only 1 valency of nitrogen is free that can be replaced by the alkyl group. Nitrogen has a valency of 3, only 1 is free for the replacement of the alkyl group. Remaining 2 are bonded to C double bond O groups of the phthalimide. That is why we cannot prepare 2 degree or 3 degree amines using Gabriel's phthalimide reaction. Another question, why can we prepare only aliphatic amines using this reaction and not aromatic amines? See, if we have to prepare aromatic amine, here the species taken will be aryl halide. Aryl halide, for example, chlorobenzene or bromobenzene can be taken. So, in that aryl halide, remember we have studied, because of resonance arises a partial double bond character, which will make this aryl halogen bond all the more strong and hence difficult to be broken. So this method, this reaction is exclusively used remember, for the preparation of only 1 degree aliphatic amine. We cannot prepare 2 degree, 3 degree amines, neither can we prepare the aromatic amines using this reaction. Next is that if you treat aliphatic amine, let us take ethylamine and treat it with acetylating agent CH3COCl, then the active hydrogen of this ethylamine will get replaced by acetyl group, resulting in the formation of the alkyl substituted amides. We will get substituted amides, and this reaction is acetylation. So the active hydrogen gets replaced by the acetyl group, forming substituted amides. Let us look this side, very important in reaction. Treat amine, 1 degree amine with chloroform and KOH. 1 degree amine, when treated with chloroform and KOH, produce foul smelling compounds called carbalamines or isocyanide. And therefore this reaction is termed as carbalamine reaction or isocyanide reaction. We get foul smelling, offensive smelling compounds called carbalamines. So this is carbalamine reaction. Now when you treat 1 degree amine with nitrous acid, you will get the alcohols as the major compounds along with the byproduct N2 plus HCl. So remember, 1 degree amine with nitrous acid will give you alcohols. Now I am treating 1 degree, 2 degree, 3 degree amine with Hinsberg reagent. Remember, Hinsberg reagent is benzene sulfonyl chloride. C6H5SO2Cl is the formula for Hinsberg reagent. Let us see how this forms the basis of distinction between 1 degree, 2 degree and 3 degree amines. So let us take a 1 degree amine and treat it with Hinsberg reagent, benzene sulfonyl chloride. So HCl will be eliminated, and further what will be formed is N-alkyl benzene sulfonamide, which when further treated with KOH will form N-alkyl N-potassium benzene sulfonamide, and that means it will dissolve in KOH. It will form a soluble salt in KOH. Why? You can see there is an active H with nitrogen, which is replaced by potassium. So it dissolves in KOH, forming a soluble salt. But if you take a 2 degree amine, it will react with Hinsberg reagent, HCl will be removed, it will form N-dialkyl benzene sulfonamide. N-dialkyl benzene sulfonamide. HCl will be lost and it will form N-dialkyl benzene sulfonamide. Further, you can see there is no active H or nitrogen. That means it cannot dissolve in KOH. So it will be insoluble in KOH. So 1 degree is forming soluble salt, 2 degrees insoluble in KOH. But let's see that 3 degree amine, nitrogen is not having any active hydrogen. So there will be no reaction with Hinsberg reagent. Very important NCERT back exercise question, that how will you distinguish between 1 degree, 2 degree, 3 degree amines. You can do by Hinsberg test using Hinsberg reagent. Or else, if you want to distinguish between 1 degree versus 2 degree, then we can apply carbalamine or isocyanide test also, where 1 degree will give you foul smell, 2 degree will not give any reaction. And if 1 versus 3 is to be distinguished, then also we can use the carbalamine test. 1 degree will form offensive smelling carbalamines, whereas 3 degree will not react with chloroform and KOH. Now we come to arrange the order type questions, and let's see aliphatic amines versus aromatic amines if we have to compare the basic strength. Then remember that the lone pair of nitrogen in case of aromatic amines is in conjugation with the benzene ring, hence involved in resonance. So not readily available for donation. Moreover, if you see in aliphatic amines, you will find that the R group, alkyl group, tends to exert the plus I effect. Because of plus I effect, it will increase the electron density on the nitrogen and makes the lone pair of nitrogen readily available for donation. Therefore, this makes aliphatic amines more basic than aromatic amines. The reason is lone pair of electron is involved in resonance in case of aromatic amines, which will, suppose it is asked, out of out of methanamine and aniline, which is having a higher pKb value. So remember that stronger the base, lesser is the pKb value. So aromatic amines will have the higher pKb value because they are less basic in comparison to aliphatic. Next, if you compare the basic strength of aliphatic amines versus ammonia, you find aliphatic amines to be more basic in comparison to ammonia. The same reason applies here. The plus I effect of the alkyl group increases the availability of lone pair of nitrogen in case of aliphatic amines. Effect of substituents on basic strength. Two types of just reverse of effect of substituents on acidity. So in acidity of phenols and carboxylic acid, we discussed that the electron donating groups will decrease the acidic strength and electron withdrawing will increase the acidic strength. Here just reverse. Electron donating group will increase the basic strength and electron withdrawing group will decrease the basic strength. Now basic strength, this is very important portion which is often asked in the board examination. Maybe in form of MCQs, maybe in form of reasoning question, maybe in form of arrange the order type questions. So let us see that in gas phase, what is the order of basic strength? 3 degree more basic than 2 degree than 1 degree in gas phase can be explained on the basis of plus I or inductive effect of the alkyl group. Now let's see in aqueous phase what is the order. The order is 2 degree more basic than 3 degree than 1 degree in case of ethyl and higher amines. 2 degree more basic than 3 degree than 1 degree in aqueous phase for ethyl amines, but 2 degree more basic than 1 degree than 3 degree in aqueous phase for methyl amines. This order can be explained on the basis of 3 factors: inductive effect, steric factor, and number 3 solvation effect, which gives the cumulative order 2, 3, 1 for ethyl and higher amines and 2, 1, 3 for methyl amines. Let's see the order of boiling point. The order of boiling point, if you see, 1 degree amines have maximum or highest boiling point in comparison to 2 degree in comparison to 3 degree amines, because 1 degree amines have greater sites available for the formation of H bond. So more extensive hydrogen bond is being formed in case of 1 degree and least is in case of 3 degree. Next, amines, if you compare their boiling points with alcohols, then we know that both forms H bond, but the H bond in case of alcohols formed are more stronger on account of greater electronegativity of oxygen in comparison to nitrogen of amines. So this is, now let us see diazotization reaction also. Aniline when treated with NaNO2 and HCl at a temperature of 0 to 5 degree. 0 to 5 degree, it will result in the formation of BDC, and this reaction is known as diazotization reaction. So we will proceed with the reactions of aniline now. Let us now study the reactions, chemical properties of aniline in form of a flowchart. When you react aniline with bromine water, you get a tri-substituted bromo derivative, that is 2,4,6-tribromoaniline. But if we want to stop the reaction to the mono-substitution stage, we need to protect the amino group of aniline by acetylation. That means we need to reduce the activating influence of the NH2 group attached to the benzene ring. Since we know NH2 group is highly activating, so what happens is that it highly activates the 2 ortho and 1 para positions simultaneously, resulting in the formation of a tri-substituted derivative. In order to stop the reaction to the mono-substitution stage, the protection has to be done. The activating influence of NH2 group has to be reduced. That is done by acetylation. So when you treat aniline by, first of all, CH3COCl in the presence of base, you get acetanilide, where the activating power of NH2 group has been reduced, since the lone pair of nitrogen here is in conjugation with C double bond O group and hence involved in resonance, due to which there arises a positive charge on nitrogen thereby deactivating it. So further, when you treat it with bromine in the presence of acetic acid, you get a ortho-bromoacetylide along with para-bromoacetylide, which further on reaction or hydrolysis with water will give you ortho-bromoaniline and para-bromoaniline. That means for mono substituted derivative, protection of amino group in aniline has to be done first by acetylation, followed by treatment with bromine in the presence of acetic acid. Very important reaction. This came in the board examination this year, this reaction. Next is the reaction with the nitrating mixture. Reaction with nitrating mixture, since we know that NH2 group is ortho-para directing. That means whatever electrophile will be there, it will come and attack to the ortho and para positions, resulting in the formation of the ortho and para derivatives. Here are two compounds, ortho and para compound. So here, if you see the nitration is being done, so you are getting three compounds. Now, please write in the comment section and let me know that why in addition to the ortho and para nitroaniline, you are getting meta nitroaniline also in substantial yield. Please let me know in the comment section. So you get a mixture of three products here, orthonitroaniline, para-nitroaniline. In addition to that, 47% of meta-nitroaniline is also obtained. Next reaction is diazotization. We will come back to this reaction because in continuation we will study all the reactions, chemical reactions of the benzene diazonium chloride or the diazonium salts. So let us first take this reaction, that is sulfonation. When you treat aniline with concentrated sulfuric acid, you get sulfenilic acid. Sulfenilic acid is actually 4-aminobenzene sulfonic acid, commonly called sulfenilic acid, and it will exist in form of its Zwitter ion because it has both the groups, acidic as well as basic. So it will form a dipolar ion called Zwitter ion, and this is the Zwitter ion of sulfenilic acid. So sulfenilic acid will be the major product formed as a result of sulfonation of aniline, treatment of aniline with concentrated sulfuric acid. Next is acetylation of aniline. Just now we saw in the presence of acetylation of aniline, in the presence of pyridine, will convert it into acetylide. That means it is C6H5NHCOCH3. It is a substituted amide. Can you name this amide? Can you give the IUPAC name of this amide? It is N-phenylethanamide, commonly called acetylide. Next reaction is again a known reaction, a very important name reaction. When you treat aniline with chloroform and KOH, alcoholic, you get a foul smelling compound called isocyanide, that is the phenyl isocyanide is obtained here along with KCl and water. Let us see if you treat benzamide with bromine and KOH. Can you convert it into aniline? Yes, we can, and it is an important name reaction called Hofmann's bromide reaction. Just now we have studied. Now, my one more question to you is why aniline will not give Friedel-Crafts reaction? Please write the answer in the comment section and let me know the answer to this very important question which is often asked in board examination. And the question is, aniline does not undergo Friedel-Crafts reaction. Now let us proceed to this reaction, diazotization, a very commonly known reaction, and it is an important name reaction which is aniline when treated with NaNO2 and HCl at 0 to 5 degree will form benzene diazonium chloride. This benzene diazonium chloride is very, very important in conversions, and let us see to what all class of compounds can it be converted to. So number one, if you want to convert the benzene diazonium chloride to haloarenes, then you can either treat it with copper salt in the presence of HCl or HBr. You may get chloro or bromobenzene. The name is Sandomir reaction. CuCl in presence of HCl or CuBr in presence of HBr may convert BDC to either chlorobenzene or bromobenzene respectively. But if you treat it with copper powder In the presence of HCl, you will get chlorobenzene. In the presence of HBr, you will get bromobenzene. And this reaction is again an important reaction known as Gattermann reaction. When you warm it with Ki, you get iodobenzene. When you treat it with fluoroboric acid followed by heat, you get fluorobenzene. Again an important reaction called Bals-Schiemann reaction. When you treat it with CuCN in presence of HCN, you get cyanobenzene. And there is a confusion between this reagent and these sets of reagent. Children, remember that when BDC is treated with fluoroboric acid, in addition to NaNO2, copper and heat, then you will get nitrobenzene as the major product. Often this question is asked in the board examination and children get confused and write fluorobenzene as the product. Remember, you have to focus on the reagents that if in addition to HbF4 and heat, if you have NaNO2 and copper, then nitrobenzene will be the major product formed in the reaction. When you treat it with warm water, it will form phenol. When you treat it with H3PO2 in the presence of water, benzene will be formed. And when, again, one more reagent to form benzene is treated with ethanol. So that ethanol will get oxidized to ethanol and it will form benzene as the major product, N2 and HCl as the byproducts. Now, next two reactions again we will study in comparative manner. Treatment of BDC with aniline or phenol results in the formation of the colored dyes. That is, when treated with aniline, it will form 4-aminoazobenzene, a yellow colored azodye. When treated with phenol, it will form 4-hydroxyazobenzene, orange colored dye. This is coupling reaction and it's a very important name reaction which is used to distinguish between aromatic amines and aliphatic amines, where aromatic 1-degree amine will give coupling reaction and aliphatic 1-degree amine will not show this reaction. So this is the summary of the chapter, children. I hope you will revise this chapter thoroughly by seeing the video lecture and you will answer all the questions I have asked you in the comment section. If you have any queries, feel free to contact and write your queries in the comment section. Prepare this thoroughly and have a nice day.